In this video, we're going to look at the relationship between 3-digit bearing and compass bearing. So this is a precedence from the last lesson in the previous video, where we looked at what bearing is and the types of bearing, which are 3-digit bearing and compass bearing. Well, if you are just watching this video and you haven't watched the previous one, please, you can go back and watch that one first, or after this you can watch that one for a comprehensive understanding of what we're going to do here and what we'll be doing from here henceforth. Okay, so let's proceed. So any 3-digit bearing can be converted to a compass bearing, and any compass bearing can be converted to a 3-digit bearing. So the reason why I'm referring you to the previous video, if you are just stumbling on this video without having watched the other ones, because I will not go back to the principles I took time to explain in the previous video. I will just apply them as we go on. So you might find it difficult to understand why certain things are the way they will be as we go on. So I would crave indulgence to pause this video or stop this one and go back to the first video in the playlist, or if you already have idea of the principles of compass bearing and 3-digit bearing, you can just go on from here. So let's go solution. Okay, so it says convert the following 3-digit bearing to compass bearing. So all the bearings here, they are in 3 digits. So number one, so in 3-digit bearing, 0 30 degrees would be in this form. This is 90 degrees, the north pole, and this is from the north to the line is 0 30 degrees. Then this should equal to this 3-digit bearing. Then compass bearing would be from this is north, and then this is south, this is east, this is west. So in compass bearing, I told you that compass bearing is usually the measurement from the north to the east, or from the south to the east, or north to the west, or south to the west. And it all depends on where this line that the angle will be measured to, that the measurement of the angle will end at, is placed. So if the line is between the north and the east, then the measurement will start from the north to the line. If the line is between south and east, like if it's like this, then the measurement will start from the south to the east. And if the measurement is between the south and the west, it will start from the south. And if it's between the north and the west, it will start from the north. So in this case, not 0 30 degrees east, 30 degrees east would be like this. So this is our line. So the principle is that your measurements should start from the north to the line, and that will give you what? 30 degrees. So this is north, 30 degrees east. That's the answer to number one. Okay, number two, it says 130 degrees. So 130 degrees in 3-digit bearing would look like this, because you already know that this is our north, and then going this way is east. So in between the north and the east is 90 degrees, and then you're going to have something like this. So this is 130 degrees. 130 degrees in 3-digit bearing. Then this should equal to, in compass bearing, it's going to be north, south, west, east. So in compass bearing, 130 degrees is from the north. Measure 130 degrees from the north, so it will be in this plane, 130 degrees. So just measure from the north pole to meet this line. First of all, this is, if you measure from the north pole to meet this line, and this is exactly what you have here. This is still 3-digit bearing using the compass, the cardinal points. This is 3-digit bearing. But now, how it can become the compass bearing is that in compass bearing, the measurement should start from the south to the line, if the line is between the south and the east, or south and the west. So as you can see, this line, which is the bearing, the direction, is between the south and the east. So we are not going to be concerned with this from the north to this one to the line. This particular measurement is the 3-digit bearing. So what we are going to be concerned, since we are considering the equivalent of this in compass bearing, so we're going to start, our measurement will start from the south to this line. So once you do that, we discover that this is now angle on a straight line. Don't forget that this is 130 degrees. This is now angle on a straight line, and angle on a straight line is like this. So here is 130 degrees, and this here is x. So find x. Remember this kind of questions, find x. So this angle on a straight line. So we're looking for this angle here. So what we do is that you're going to say, so let's say here is theta. So we say theta is equal to 180 degrees minus, okay, let's put it this way. 180, so here 180 degrees plus theta is, 130 degrees rather, 130 degrees plus theta is equal to 180 degrees. What's the reason? Angles on a line. Angles on a line, that's the reason. So theta is equal to 180 degrees minus 130 degrees. So theta is equal to what? 50 degrees. So this angle here is 50 degrees. So if that is true, then 130 degrees is equivalent to south. Therefore the bearing is south 50 degrees east. That's what it's equivalent to. So 130 degrees is 3-digit bearing, but in compass bearing, it is south 50 degrees east. So that's it. Number 3. It says 244 degrees. 244 degrees in the 3-digit bearing would be like this. So this is the north, and then remember that if you are coming from the north and you're going to the western direction, or you move westerly, that would be 270 degrees. So 270 degrees less than is better than 244 degrees. So it should be like this, which if you are going to the south is 180. So 180 moving this way, you are going towards the westerly direction. So from the north, remember it's 3-digit bearing, so I don't need any of this. It is just for reference purpose. So I'm going to move it like this. So from the north to this line is 244 degrees. So this is equal to what we are going to get from our compass bearing. So if you represent this, you can use our cardinal points to represent this bearing in 3-digit bearing. So if you use our cardinal points, so 244 degrees will be here. So if you use our cardinal points to represent 3-digit bearing, they are measured from the north only. From the north only, this is 244 degrees. However, our intention is to get the equivalent of this in compass bearing. So the equivalent of this in compass bearing is going to be gotten when you measure it from the south to this line, from the south to this line only. So north, south, east, west. Okay, so what are you going to do now? Now what you discover is that from the north to the south is 180 degrees, right? So 180 degrees plus something here gave us the whole of 244 degrees. Or you can say from here, from this old point to this point is 244 degrees. Correct. But what you should note is that from this north to the south is already angle on a straight line. That's angle on a straight line. So from the north to the south is 180 degrees. And then from this south, you have a slight deflection like this. So we want to know here. So, but you know that from this north also to here, that's the whole of here to here, that gives us 244 degrees. So if you want to get here, you need to remove this theta from this 200 from this. You need to remove 180 from here to here is 180. Remove 180 from 244 to get this remaining angle, because initially how you got 244 degrees was this angle from here to here 180 degrees plus from here to here. So let's put it this way: theta plus from this point to this point, not to the south, which is 180 degrees, is equal to 244 degrees. That's the whole angle from the north to this line. Remember, it's 3-digit bearing we are converting from. So this 3-digit bearing we are converting from to compass bearing. So from here to this line is 244 degrees. So 180 degrees plus theta is equal to this whole angle. So now theta is equal to 244 degrees minus 180 degrees. So theta is equal to what? Let me get it here. 244 minus 180. So this is 4. 14 minus 8 is 6. The answer is 64 degrees. So when you add, if here to here is 64 and here to here is 180, then the whole of from the north to this line, you know, is simply from here to here plus here. That will give you 180 plus 64 to give you 244 degrees. So in compass bearing, therefore, the bearing is south 64 degrees west. South 64 degrees west. That's number 3. Number 4, 300 degrees. So 300 degrees in 3-digit bearing would be, so remember, from the north, and then if you are going to the westerly direction, that's north to the west, as from here to here. From the north down to this point is 270 degrees. 270, and we are to show 300 degrees in diagram form as a 3-digit bearing. So this will be 300 degrees to this like this. So from the north to this line will give us 300 degrees. This is the 3-digit bearing. So let's represent this in using the cardinal points. So if here is, remember, north is 0, east is 90, south is 180, west is 270. So 300 is between 270 and 360 degrees. It is in the 4th quadrant in our peculiar 3-digit bearing quadrant. This angle is in the 4th quadrant because the range is in the 4th quadrant is between 270 degrees and 360 degrees. The 300 degrees is within that range, so it is in this quadrant. So what do you do? Just draw a line. So let's say this is our 300. So from the north to meet this line, because compass bearing, the principle is that the measurements start from the north only to wherever the line is. So you meet it here, so you draw your arrow to indicate that the measurement started from here and ended when it met this line. So this is 300 degrees. Now, to get the equivalent of this in compass bearing is that the measurement must start from the north only. So if from the 3-digit bearing, your measurement started from the north to meet this line, and compass bearing says the measurement must start from the north only to meet the line. So it means you're going to move like this and stop here. So what do you observe? This is angle at a point. Okay, so we call it for your theta. So to get the value theta, we know that theta plus 300 degrees is equal to 360 degrees. Why? Because, let me start again. Theta plus 300 degrees is equal to 360 degrees. Why? Angles at a point. Angles at a point. Okay, so theta is equal to 360 degrees minus 300 degrees. Theta is equal to 60 degrees. So this angle here is 60 degrees. So therefore, the bearing is not 60 degrees west. That's the bearing. Number 5, 275 degrees. The 275 degrees is in the 3rd quadrant. No, 275 degrees in the 4th quadrant. So the 3rd quadrant is within 180 to 270. 275 degrees is something like this, because this is the western direction and it's 270. So so from the north to this line, that will give us 270 degrees. So this is equal to 275 rather. 275 degrees. So this give us like this. So from the north to this line is 275 degrees. So this is still 3-digit bearing. I use 3-digit bearing on cardinal points or the compass. So south west. Now, to get the equivalent of this in compass bearing, our measurement will start from the north pole only. So from the north pole to this line is this. What do you observe? This is angle at a point. So since it's angle at a point, let's call here is a beta. So beta is equal to beta plus 275 degrees is equal to 360 degrees. And that's okay. Why? So we say angles at a point. That's the reason. So beta is equal to 360 degrees minus 275 degrees, and beta is equal to 360 minus 275. 15 minus 7 will give us 8. That's 85 degrees. So in compass bearing, 275 degrees is same as bearing is bearing is north 85 degrees west. So 275 degrees as 3-digit bearing is same as north 85 degrees west as compass bearing. That's the equivalent or the relationship. Convert the following compass bearing to a 3-digit bearing. Solution. So now we're going to convert from compass bearing to 3-digit bearing. So let's represent north 65 degrees east. So in 3-digit compass bearing, this will be 65 degrees is like this. So from compass bearing is always from the north or the south. So this is between the north and the east. So from the north here, that will give us 65 degrees. All right. Now, to get the equivalent of this in the 3-digit bearing, we're going to also use our compass also again. So 65 degrees be like this. 65 degrees. So if you measure from the north, for a 3-digit bearing, your measurement must start from the north only. And when you start from the north, anywhere the line is, turn your angle of rotation until you meet the line, and then stop there. So if you start from the north and get to where this line is, and you stop, you still get 65 degrees. So what you have here as 65 degrees is 3-digit bearing. Since you only have 2 digits here, just add 0. So it becomes 0.65 degrees. That's it. Number two, south 40 degrees west. South 40 degrees west. South 40 degrees west. So 40 degrees west in compass bearing is going to be like this. South and west, so it's going to, okay. South 40 degrees west. Measurement was from the south to the lines. This is 40 degrees. This is west, north, east, and south. So this is south 40 degrees west. Now, to convert this to 3-digit bearing, this is equal to, use our compass notation again. So this is north and east, this is west, and this is south. Our line is here as 40 degrees. Okay. Now, from what we know, 3-digit bearing must start from the north only. So you start from the north and then you turn until you meet the line, then you stop. So from the north to this line. So what will be the whole of this angle? And what you're going to see, let's call this theta. So what you see is that from the north to this line is 180, and from this line to this point here, so okay, from this south to this line is 40 degrees. So theta will not be 180 degrees plus 40. So theta is equal to 180 degrees plus 40 degrees. I want to assume that you understand what I just did. This from the north to this line is the whole of from the north to the south plus the south to this place, because that's what it entails. So if you are getting from the north to this line, which is the whole of it, the whole distance, then that be from the north to south, which we know to the 180 degrees angle in a straight line. Then from the south to this line, which is already given to us as 40 degrees. So theta is equal to 180 degrees plus 40 degrees will give us 180, 40, 0, 8 plus 4, 12, 220, 220 degrees. So in 3-digit bearing, south 40 degrees west is equivalent to 220 degrees in 3-digit bearing. Number 3, south 45 degrees east. South 45 degrees east. So south 45 degrees east in compass bearing would look like this, between the south and the east. So your measurement will start from the south pole only to meet the line. So this is 45 degrees. Now, okay, north, west, east, and south. Now let's get the value of this in 3-digit bearing. So using our compass also, this is north and this is south, west, and east. So south 45 degrees, east, this is 45 degrees. Now, in 3-digit bearing, your measurement must start from the north until it meets the line. So start from the north to meet the line here. So let's call this theta. So what do you observe? this line did not cross to this part, so because it did not cross, we are not going to add. Rather, what you can see here is angles on a straight line. This one angle and this another angle. So theta plus 45 degrees equal to 180 degrees. Reason angles on a straight line. Angles on a straight line. All right. So theta is equal to 180 degrees minus 45 degrees. So theta is equal to 180 minus 45 degrees. 180 degrees minus 45 degrees. 5 degrees. 3, and 1. That's 135 degrees. So theta is equal to 135 degrees. So 45 degrees is the equivalent of 135 degrees is a 3-digit bearing. That's what it is. Okay, I felt this would be necessary before we end the class on this topic. I felt this would be necessary because we will be drawing on the knowledge of this in the subsequent lessons that will be taken from here. So what you observe here is a series of angles formed when transversals cut parallel lines. So from what we call transversal or parallel lines, first of all, are lines that move in the same direction but they never meet. So you have this line, you can call it PQ, you can call this ST. When two lines like this move in the same direction but they never meet, we call them parallel lines. Now when a line cuts a parallel line, we call that line a transversal. So this is a transversal. So let's call this MN, line MN. So when line MN cuts the parallel lines PQ and ST, we're going to have series of angles formed, a lot of angles formed. And these angles that are going to be formed, they have a kind of relationship existing between them, and you have to know them. So we have examples of such angles. We have alternate angles. We have interior opposite angles. We have corresponding angles, and then we have vertically opposite angles, and then we also have angles and sum of angles. But let's just look at this 4 especially. Okay, so let's look at what we have here. So now this part here, whenever a line, okay, let me just use this part. So what we have there is something like this, and then like this. So we have A and B. So what do you notice? You see that in this way, A is equal to B. A is equal to B, and then if you have here, this is C, and then C is also equal to D. What's the reason? These are vertically opposite angles. Vertically opposite angles. So that's one thing you need to note. You're going to see some of these cases when we start taking questions on bearing. So I don't want us to be confused when I start solving and when I start putting these things on the board, and you'll be wondering how we got to that point. So just let me write this as a note so that you can be familiar with them, or let them be as a kind of a refresher to you. Now, number 2, the next thing you need to look at is this. Not only do we have vertically opposite angles here, we also have interior opposite angles. So interior opposite angles are going to be like sum of angles. So interior opposite angles are in this form. So here we have transversal, and then we have an angle here. Yes. So here we have D, and then here we have F. So, and also on this side we have C, and then we have here E. Okay, so now what you see is that for interior opposite angles, according to the name, as the name implies, interior opposite. Interior means inside. So this D and F are this, and the theory for interior opposite angles is not that of equality, it's rather that of sum. So it says D plus F. D plus F is equal to 180 degrees, as much as C plus E. C plus E is also equal to 180 degrees. So what is the rule? So we say sum of interior. The reason is that sum of interior opposite angles are supplementary. That's they're equal to 180 degrees. Sum of interior opposite angles are supplementary. So D plus F is equal to 180 degrees. C plus E is also equal to 180 degrees. So why do we call them interior? Interior because they are inside the transversal and the parallel line. So not that one is inside and the other is outside. This one is inside between this line and this transversal, this parallel line rather, and this F is also inside. So they are both opposite to each other, but they are inside the transversal. So we call them interior. All right. So the next one is corresponding angles. What are corresponding angles? Corresponding angles are angles that are in this form. One is going to be outside. You have here. So let me find. So we have A and E, and then we have here B and F. So for corresponding angles, A is equal to E, and then B is equal to F. B is equal to F. What's the reason? Corresponding angles. Corresponding angles. So why do we say they are corresponding? They are corresponding when these are transversal. These are transversal. So if a parallel line cuts the transversal, if one angle is here, which is A, and the other is here, F, we say A corresponds to F. So what you're going to look out for in corresponding angles is that they must be on the same side of the transversal, but one must be outside and the other must be inside. They must be on the same side of the transversal. In this case, A and F. One is outside, which is A, and the other is inside. So in this case, they are corresponding. So if another one is here, and we have another angle here, which is in this case, what we have there is D. This is D, and here is G. So we say D is equal to G, and what would be the reason? Corresponding angles. They are corresponding. Then the next one we are going to look at is alternate angles. So let's figure out alternate angles. So alternate angles is C is equal to F, and C is equal to F, D is equal to E. What's the reason? So we say alternate angles. So alternate angles are angles of this form. So these are transversal. These are parallel lines, and these are transversal. So if we have an angle here, alternate angles are always inside the transversal. So inside the parallel lines and the transversal. So if this is C, and then this is F. So for alternate angles, just like interior opposite angles, for alternate angles, they must be on either side of the transversal, but both of them must be inside the shape, inside the shape formed by the two parallel lines. So none of them should be outside. This one shouldn't be outside. This shouldn't be outside. Both of them should be inside or between the two parallel lines. Both of them should be between the two parallel lines, but on either side of the transversal. So this one is on this side of the transversal. The other is on this side of the transversal. And both of them must be within the two parallel lines. So when that happens, the angle formed here and is equal to the angle formed here as a result of this transversal cutting the two parallel lines. So C is equal to F. So which other from here, C is equal to F, D is equal to E. C is equal to F, D is equal to E. And if you come here, K is equal to N, and then N is equal to L. And then when you come here, let's see if there's N here. Okay, yeah. So no, we cannot, P and K, yeah, one is outside. So those are not alternate angles. So that's for alternate angles. So what other one have I not looked into? So I've seen 1, 2, 3, 4. So I've touched on this 4. Okay, sum of angles on a straight line. So the next one we're going to look at is sum of angles on a straight line. So we have here E plus F. E plus F is equal to 180 degrees, as much as C plus D. C plus D is equal to 180 degrees. So what's the reason? Sum of angles on a straight line. Sum of angles on a straight line. Okay, so now what this implies is sum of angles on a straight line, sum of angles in a straight line, sum of angles in a straight line. So okay, so what it implies is that, let's look at what E plus F. Where's E plus F? E plus F. So what you observe is that this is a straight line. It's a straight line, and then you have a line like this. This is F, and then this is E. So what? This is angles on a straight line. So E plus F is equal to 180 degrees. Same thing with C plus D. C plus D, which in this case is an inverted form. In this form, this is C, and here it's D. So angles on a straight line is, or they are equal. So they are equal to 180 degrees, or they're supplementary. So these are a few things you need to note. If there is any that I couldn't remember to add here, maybe when we are when I'm taking the lesson and taking the examples, I will bring it to your notice and I will expatiate on it. Express the true bearing of 250 degrees as a compass bearing. So 250 degrees as a compass bearing will give us 250 is here in this quadrant. So as a compass bearing, first of all, as a 3-digit bearing, to be from the north to this line, that's 250 degrees. Then as a compass bearing, it's going to be from the south to the west, so from the south to the line. So let's call it theta. So what will be theta? Remember that from the north to the south is 180. So theta plus 180 degrees is equal to 250 degrees, and theta is equal to 250 degrees minus 180 degrees. Theta is equal to 250 minus 180 minus 180. 15 minus 8 is 7. That's 70 degrees. So that would be south, 70 degrees west. So our answer is here. What option is it? Option C. So this is the answer. Let's see. Number 2. A bearing of south 40 degrees east is same as south 40 degrees east. South 40 degrees is southeast, north, rather, east, south, west. South 40 degrees east is going to be like this. So here that will be 40 degrees. Now this is compass bearing from the south to the line. 2-digit bearings from the north to this line. North to the line. So that will give us. So this now is theta, angles on a straight line. So theta plus 40 degrees equals to 180 degrees, raising angles on a line. And so theta is equal to 180 degrees minus 40 degrees, and theta is equal to 140 degrees. So south 40 degrees east is same thing as 140 degrees. Number 2, that's south 40 degrees east is same as 140 degrees. The option is not here, so but that's our answer. Number 3. The bearing of south 40 degrees west is the same as south 40 degrees west. South 40 degrees west is going to look like this. 40 degrees west south. So in this direction, gives us 40 degrees south, north, west, east. So for the convert this to 3-digit bearing, move from this north to this line. We'll call this beta. So beta plus beta is the whole of the distance, or the whole of the angular measure or turn from the north to this line. Whereas from the north to the south is 180 degrees, and then from the south to this line is 40 degrees. So beta is equal to 180 degrees plus 40 degrees. So beta is equal to 180 degrees plus 40 degrees will give us 220 degrees. 180 degrees 40, 0, 8 plus 4, 12, 2, 220 degrees. So south 40 degrees west is equivalent to 220 degrees, option D. And then number 4. Number 4. The bearing of south 50 degrees west is same as south 50 degrees west. So south 50 degrees west is going to look like this. 50 degrees west. So this is north, south, west, east. So the 3-digit bearing or measurement will start from the north to this line. So let's call this alpha. Now alpha is the sum of 180 degrees from the North Pole to the South Pole. 180 degrees plus, sorry, from the north to the south, 180 degrees, then from the south to this line, that will give us 50 degrees. So alpha is equal to 180 degrees plus 50, 0, 8 plus 5, 13, 2. That's equal to 230 degrees. So alpha is 230 degrees. So the equivalent of south, 30 degrees west in 3-digit bearing, also 3-digit bearing is equal to 230 degrees. 230 degrees. So this is option D. Option D and C. So this one that doesn't have option. Number 3 was no option. Option D as well. Option D. So those are our answers.